Okay, in this video, we are going to talk about how we can graph a function that is given to us, and it's been given to us in standard form. Now, if we're going to talk standard form, we need to actually think about what does that mean. Remember, standard form, we can say is y equals, or you could write f of x, but y equals a x squared plus bx plus c. This is exactly how this equation has been given to me, or this function has been given to me. When we want to graph from standard form, as explained here in the directions, we start by plotting the vertex. But that means we're going to have to find the vertex. So remember, a vertex from standard form, we start by finding the AOS. And that is the axis of symmetry. That magic line that we use the little dotted line for that divides it in half to make the perfect parabola. Our formula is x equals negative b over 2a. So we're going to use that. X equals, now go find the b term. Remember, that is whatever's just with x. So if I have an x, the b is right in front of it. So I have 6. So negative 6 over 2 times a, which is, well, that's a 1. 2 times 1. So x equals negative 6 over 2, or I could say that x equals negative 3. So now I know my x, or my axis of symmetry. Now think about that. If I want to plot a coordinate, I need x and y, so I'm halfway there. I'm going to go find the next part. And I'm just going to plug it back in and say, well, y is going to equal x squared. Well, instead of writing x, I'm going to write negative 3. So negative 3 squared plus 6x, so 6 times negative 3 plus 10. We're just plugging it right back into the equation exactly where the x is. And then we'll follow our order of operations. I should exponent first, so negative 3 squared is like negative 3 times negative 3. So this is going to be 9. 6 times negative 3 is negative 18. And then I'm going to add the 10. Now I like to put the positives together because I have a 9 and a 10. 9 and 10 makes 19. And 19 minus 18, well, that would be 1. So y is going to equal 1. Well, there's my vertex, xy. Negative 3 was my input. My output was 1. I can go graph that. Negative 3, so negative 3 is on the x, positive 1 up. I'm going to click. And now I can start thinking about my parabola. Which way is it going to go? Well, I know it's going to go up because it's positive. But I need another point. So from standard form, we have the option of using the Y-intercept because it's nice and easy. Because if you think about it, the Y-intercept is where x equals 0, right? Well, if I plug that into that equation, I'm going to have y equals 0 squared plus 6 times 0 plus 10. Well, 0 squared is just 0. 6 times 0 is just 0. So really all I have left is the constant at the end, which is 10. So when x is 0, my y is 10. And if that is on the graph and that fits, I'm going to go click that one. That'll be the easiest one to use. And if you notice, as soon as I click it, IXL goes ahead and mirrors that for me on the other side of the axis of symmetry, making a perfect parabola. All right, so here we have our next problem. And again, we're still in standard form. They've given me the equation this time, f of x equals negative 8x squared plus 16x plus 1. So I'm going to go ahead and say, well, that would be y equals ax squared plus bx plus c. Ax squared plus bx plus c. All right. I'm going to plot the vertex, but to plot the vertex, I'm going to need to actually find it. I start with the AOS, which is where x equals negative b over 2a. So here x would equal negative, well, what is b? B is 16, so negative 16 over 2 times, well, the a is negative 8 So let's go ahead and simplify. That would be negative 16 over, well, 2 times negative 8 is also negative 16. And negative 16 divided by negative 16 is going to equal positive 1. So we're halfway there. We know x. We need to go find y. So I'm going to plug that back into that equation that we've been given. So y equals negative 8, and then I have a 1. So 1 squared plus 16 times 1 plus 1. All right, so y equals, now 1 squared, that's 1 times 1, right? So that's 1, and negative 8 times 1 is negative 8. 16 times 1 is plus 16, and then I have the plus 1 on the end. Now again, I like to put these two together. I like to say, well, 16 and 1 is 17, and 17 and negative 8, or subtract 8, would be 9. So here, my input was 1, my x was 1, my output was 9, input, output. And I can go put that on my graph, 1, 9. Well, now I need a second point. Now, could I use the y-intercept on this problem? Would that make sense to do so? If I plugged a 0 in, where would I end up? 0, 0, I'd have just 1, right? So we could do that. I'm going to go to 0, 1, and I'm going to click. And that should give me a perfect parabola. Let's try it. Oh, great job. Okay, let's see here. And I'm going to see if I can grab a new equation for us. All right, so we have a new function here. F of x equals 5x squared plus 20x plus 15. Remember again, that's y equals ax squared plus bx plus c. Vertex, we start by plotting the vertex, or standard form. We'll start with the vertex. So a of s, so axis of symmetry, where x equals negative b over 2a. Negative b, that would be negative 20 over 2 times 5. So x is going to equal negative 20 over 10. Well, negative 20 divided by 10 is just negative 2, right? So x equals negative 2. We're halfway there. We now need y. So I'm just going to plug that back in. Y equals, a was 5, so 5x squared, negative 2 squared, plus 20 times negative 2 plus 15. Now let's think here. Square first. So negative 2 times negative 2, that's what squared means, is 4. So I'd have 4 times 5, which is 20. I have 20 and negative 2. 20 and negative 2 makes negative 40 if I multiply. And then plus 15. Again, I like to put the positive. So 20 and 15 is 35. And 35 minus 40, yeah, that should be negative 5. So my vertex is negative 2, negative 5. I'm going to go put that on my graph. Negative 2, negative 5. I know this is going to open up because the a is positive. And, well, in standard form, I like to use that y-intercept if I can. So I go up here and I look. If I plugged 0 in for x and 0 in for x, both of these would be 0 plus 15. But if you notice that 0, 15 is not on my graph, so that is not an option. But that's okay. I could use another point if 0, 15 is not on my graph. So instead of coming here, because I know that's going to run off my graph, I'm going to go back 1. And I'm going to try negative 1. Just like we did with the vertex form, I'm just going to plug it in. I'm going to say, okay, so I have y equals, I'm going to use where x equals negative 1. So 5 times negative 1 squared plus 20 times negative 1 plus 15. Now negative 1 squared, negative 1 times negative 1 is 1. So 5 times 1 is 5. 20 times negative 1 is negative 20. And then I would have plus 15. Well, 5 and 15 is 20, and 20 minus 20 is 0, right? So my coordinate here, when I input negative 1, my output was 0. Well, that's going to fit on my graph. There's negative 1, 0 is right here. And when I click it, it makes a perfect parabola. So when we can use the y-intercept, we do, because then it's less math. We can just find the c at the end. But if the y-intercept's not on the graph, you're going to have to use another point. You could use any of them, but what I like to do is go to my vertex and then just pick over one. That way I know it's super close and it should be on my graph. So there you have graphing in standard form. Start with the axis of symmetry, find x. Once you know x, you can find y, and now you know your vertex. And then after you have your vertex, pick your next coordinate. If you can't use the y-intercept, pick a coordinate right next to your vertex to see if that works first. As always, you can pick any, but you're going to have to be careful because if it's not on the graph, you'll have to try another.